if k is a common multiple of 75, 98, and 140, which of the following must be true? So what is it saying? So 75, 98, 140, they're going to have lots of multiples. They're going to have, infinite multiples, in fact, in common. But we want to think what must be true of all of them. So what must be contained in every single one of those multiples? And so they're really asking here for what is the least common multiple of 75, 98, and 140, because any multiple of these three numbers is always going to contain the least common multiple. So how can we find the least common multiple of these three numbers? So we need the minimum number of prime factors to make all three of these numbers. So let's break them up into their prime factors. So 75 is 25 times 3, and 25 is just 2 5s. So 3 times 5 times 5, 98. What is that? So 49 times 2, and 49 is just 7 times 7. So 2, 7, 7. And then 140 is 70 times 2. This is 35 times 2. 7 times 5. So 2 2s, a 5, and a 7. So if we want the smallest number possible, that includes all three of these numbers. So what do we need? So let's start with the 75. So to make the 75, we need a 3 and 2 5s. Okay, then we need to also be able to make a 98 out of these factors. And so we need a 2 and 2 7s, and we don't have any of those. So we're going to have to add all of those into our number. And so the 140, it looks like is going to benefit from what the others contributed. Free writing. So to make the 140, we need 2 2s, a 5, and a 7. So we already have 1 2. So how many additional 2s? We just need one more. We need 1 5. Well, we already have 2 5, so we don't got to add any more of those. And we need a 7, and we already have 2 7s as well. So we don't need to add anything more there. So this number here, so 2 times 2 times 3 times 5 times 5 times 7 times 7 should be the least common multiple of 75, 98, and 140. And therefore, all of our multiples of these three numbers at a minimum have to contain these prime factors. So what must be true? So k is divisible by 9. So to be divisible by 9, you need to contain 2 3s. Here we only have 1 3, so k does not have to be divisible by 9. So anything with a 1 can be eliminated. C and E. K is divisible by 49. So if it's divisible by 49, it's going to contain 2 7s, which we have. So all of our multiples will contain 2 7s, and therefore they're all going to be multiples of 49. So 2 has to be true. So based on that, B can be eliminated. K is greater than 14,000. Oh, so we're going to actually have to find what this K is. What is this? So I got my 2 5s give me 25. My 2 2s give me 4, so 25 times 4. So that's a 100 right there. And then what's 49 times 3 is what I have left over. 49 times 3 is, so 7, 147. So my least common multiple is That wasn't as bad as I expected. So 147 times 100, which is 14,700. So if my least common multiple, the lowest common multiple I could possibly have is 14,700, then all of my multiples are definitely going to be greater than 14,000. So statement 3 is true as well. So A is eliminated, and D is our answer. This is a good question because it deals with divisibility, which is a very useful concept to know. Probably the most useful concept in my opinion.